Welcome to this CS210 computer architecture video where we'll discuss counting in binary. So you can also watch other videos, but I'm just going to give a brief video overview of this. And one way to do it is to look back at the old odometers that used to be in cars. Now, an odometer is something that measures how far a car has traveled, and all cars have them in the dashboard. They're digital nowadays, but before they became digital displays, they used to be these wheels that flipped over. So they had a wheel that had numbers from 0 to 9 on it. And as you moved another mile, then the wheel would increment 1, moving to the next number. And when it got to 9, the last number, it would roll back to 0, but that would cause the next wheel up here to flip up to the next number. So we're going to do the same thing with binary, except for now our wheels only have 2 numbers on it. Now, hopefully from previous videos, you know that decimal systems have 10 different characters that can represent 10 different numbers. We always start counting with 0, so that's 0 through 9. Binary only have 2 characters that can represent 2 different numbers. So we're going to need a lot more what we do call digits in our decimal system, but we call these bits. So let's go ahead and count from 0 to 7 in binary. And so we'll start with 0 to 7, and we'll make sure we have 4 bits to be able to count. So of course, the very first number, all 4 of the bits are all zeros. Now inside of the computer, these can be transistors, wires, areas on a magnetic disk like a hard disk, or back in the old days, a floppy disk, or even our solid state drives like our USB keychains or USB drives that we can use to save data. There's 4 little areas to store a 0 or a 1 value. So that's the very first number. And then as we want to increment and move to the next number, we take the lowest bit or the least significant bit, which is on the right side, and we increment it by 1. Then if we want to increment this again, we're going to increment that by 1. But since there's only 2 numbers on this, that means that this one is going to roll back and 0 is going to be the next number. And whenever a 1 reverts back to a 0, that means the next guy up reverts back up to a 1. So let's go ahead and try that. Okay, and then the next number, we're going to increment to the lowest, least significant bit again, which is on the right side. So the next number, 3, is that in binary. Now we're going to increment to 4, and this is a little interesting case because this guy is going to roll back to 0, and this guy is going to roll back to 0. So this is the same case that we would have with the number 99. So when we're 99, if this rolls back, the next number is going to be 0. So this will roll up to a 0, and then that will cause this guy to move to the next number, which will be a 0, which causes the next guy, and you can always add zeros in front of numbers, it doesn't change the value, but it will cause the next guy that was a 0 to roll up to a 1, and we get 100. So now, in this case, it's the same idea. These 2 guys are going to flip up, causing that guy to flip up too. And now I'll move a little faster. And there's our binary numbers from 0 to 7. Now, if you notice, it's always 0. This most significant bit on the left is 0 for all of them. So it takes 3 bits to represent a number between 0 and 7. If we want to go bigger than that, then we're going to need a 4th bit. So now let's count from 8 to 15. Okay, so moving on from the next number from 7, if we're going to increment this guy, that's going to cause him to flip over, which is going to cause him to flip back over to a 0, which is going to cause him to flip up. So the next number is 1000, or If it was a decimal number, you would say 1,000. And we can keep counting. I'm going to do this a little faster now. And so now we are at the limit of numbers that we can represent with 4 bits. If you notice, all possible combinations of ones and zeros are used up. So if we want a number bigger than 15, we're going to have to add a bigger bit.